Hey everybody, we're back again. It's Rocket League Part 2. Let's see if we can remember where we were. Okay, so if I remember correctly, we are driving around on a blue field. Alright, there we go. So a red car and a blue field. So let's change a couple things. I was looking at the code a second ago before I push go, and I feel a little bit uneasy about some of the trig that I used. And I feel like it's working, which is like I thought, but we're kind of being unconventional with the way we're using angles, so I'm going to change that. But not before I change some more fun stuff first. Let's first go make our field bigger. How about some big field? 1200 by 800. Okay, so a lot bigger of a field. And let's change the background color. So RGB. So I want it to be a green field, but not like super duper green, just like medium green, like the color of the font there. Is that any better? Oh yeah, definitely. I could probably even make it wider just for fun. Can I make it just a little wider here? Can I do like 1500, 800? Oh yeah, okay, that looks like a field now. It's like a sideways Rocket League, so left and right. Okay, so let me show you what kind of bothers me. So if I'm facing this way, you know how we called this 0 degrees? So I guess going this way would be 0. It's actually kind of not cool. And I also, when I said I turned right, I'm actually increasing the degrees. Right? If you look back in our code, like when I turn right, let's look at our car function. Turn right, I'm adding to the angle. So that's actually kind of not how it works. The way mathematicians, I guess, have agreed to think about angles is like this. So this one's with degrees. Can I find one that doesn't have degrees, like radians maybe? Because we're using radians. Unfortunately, if you don't like radians, then I guess you are left out of the party. So here's radians and degrees. So radians, much like you can see, you guys, are like just a different way to visualize angles. So do you guys see where 0 is? So you can think of this like degrees, right? So instead of this being 30 degrees, it's just called pi over 6. And this pi over 2 is associated with 90 degrees. So it's just a different, like, and so I guess where would 1 radian be? So think about it this way. So pi is approximately 3.14 or whatever, right? If you divide that by 3, so this is approximately 1 radian right here. Like, see that angle? So if you want to think about it, what's a radian? Well, it's like, I'm not going to do a math lesson right now, but there's 1 radian right there. And if you want to chunk out a circle, halfway around the circle is pi radians. All the way around is 2 pi. Okay, so that's it for the for the radians lesson. We're just going to go moving on forward. Hopefully you have your trig background. Okay, so do you guys see where 0 is? 0 is pointing way off to the right. So, and you notice turning left, I suppose, right? You imagine a car facing this way. Turning left is the positive direction. So this is actually kind of like a problem. I'm going to try to go agree with the unit circle because I really understand angles this way a lot better than I do in the way that I program this car. So let's change things a little bit. Okay, so the angle is 0, but if the angle is 0, how should the car be drawn? I guess it should be drawn like this, right? I'm just going to look at this. So if the angle is truly 0, then it should look like that, and it's pointing off to the right. So if I turn left, that actually increases the angle. Can you kind of see that? If I turn left, the angle is going in the positive direction. This is the positive. Counterclockwise is actually positive. So let's do that. Let's turn left, have turn left add to the angle, and let's have turn right subtract from the angle. All right, now this is going to change things drastically right here. Okay, so for those of us, let's get this fixed. I don't know if I haven't gotten this to work yet because we need to fix this part. If I'm going forward at 0 degrees, I'm only changing the x. If I'm going forward at, say, 90 degrees, I'm only changing the y. So what I'm going to do is the x is changing always by the cosine of the angle. Now just a brief, like 10-second explanation about what the cosine of an angle is. So think about the cosine, or think about this angle right here. Do you see this? This angle pi over 6th. That's that angle. It's more horizontal of an angle than it is a vertical angle, you know what I mean? So the horizontalness of the angle, or the sidewaysness of the angle, is its cosine. So this cosine is pretty high in relation to its sine, which is the vertical. So here's the cosine of pi over 6. It goes out far. The cosine of pi over 3, as you can see, is not quite as far. So as angles kind of go up towards this way, and then right here, the cosine of this angle is 0. if we keep going around, the cosine ends up being negative, and so on, right? So the cosine is actually measuring the x-ness, and the sine is measuring the y-ness, or the height of the angle. So this is actually going to agree with common sense-wise. So y is actually going to change by the sine value, which makes a lot more sense for those of us who have some trig background. The y is associated with sine, and the cosine is associated with the x. So the plus equals, yeah, that should be, so this is a lot better, I think. So I don't know if this is going to work yet. Maybe there's an issue. Let's see. Maybe it does. Maybe it works, but I don't know. Okay, so going forward, turning left. Okay, so turning left, it's a little bit backwards. A little bit backwards, and let's figure out why. So I'm actually going to log the angle and see what it thinks. So as I'm turning, so live troubleshooting, exciting stuff. Let's log this dot angle. Now it's in radians, so I know it's going to look confusing, but approximately all the way halfway around a circle is about 3 radians. All the way around the circle is, 6.5 or so radians. Let's log the angle as I'm turning and then watch it change on the console. So here we go. Let's inspect. Let's take a look at the console. So if I tap the turning button, oops, I need to click on the canvas and then tap the turning button. So it says that my angle is getting more and more positive, so which is interesting because the shape appears to be rotating in the opposite direction. So I'm trying to turn left, and the angle is indeed getting more positive, but it's not drawing it as such for me. So which is weird. Okay, so let's refresh this. So what does forward look like? So that is forward. I'm trying to think. So it's rotating. Perhaps, you know what? Perhaps the rotation of the drawing object is clockwise being positive. So it looks like when I'm going positive, I'm actually the drawing object is rotating clockwise. So perhaps P5's drawing object rotates with the opposite directionality of the unit circle here. So I can just fix that real quick by just saying I'm going to rotate the negative angle. And then that should fix it. So rotate 1 times, negative 1 times this angle. And, oh, there's the cat again. Hi. Okay, let's see if so that makes more sense. Okay, so now it feels like it did a second ago. So I think actually what's going on is I would like to agree with the unit circle. And if P5's drawing object rotates where it says clockwise is positive, well, I'm just going to kind of like override that by rotating the opposite, just by kind of reversing that, you know what I mean? So now I feel like I can think in, so let's think of it this way. I'm going to refresh. Like if I'm turning left, here we go. I'm pointing towards the 0 direction. Think back to that diagram. And now I'm starting to get more and more positive. Remember what I said about halfway around the circle is about 3-ish radians? So here we go. Does that look like it's making sense? I'm getting close. There you go. Yeah, so pi is right in here, just past pi. All the way around would be like, 6.5, 7. And there we go. Right? So we're right around there. So this makes more sense to me now as I'm driving around. This is what I want. This is what I'm going for. Okay? So 0 being, off this way. Cool. Okay, that makes me feel better. So I feel happier about that. All right, so let's do some other stuff. Let's not have this car be so like, I'm going top speed, I stop. Let's actually have it be a little bit more realistic. Let's have some acceleration. Okay, so what is this going to mean? Okay, let's give it a try. I don't know. Let's say that when we go forward, we're actually going to, the velocity is actually going to be 0. The car's velocity should be 0 to start with. That actually starts, that maybe had a lot of people kind of shaking their head like, the velocity of the car isn't 3 when you start it, so why did you say? That's actually probably the right hunch to have, and so we're kind of revealing some of that maybe sort of questionable design at first. So let's fix it. The velocity is 0, but maybe what we're thinking of is there's really like there should be some acceleration too. And the acceleration of the car is, I suppose, let's set some value. How about like, I'm just going to take a guess, like, let's make the acceleration like 1 for now, right? So, and we also need, I guess, a top speed. So this dot max speed. And usually when you set these, good programming practice is these constants are usually written like this, where they don't change value throughout the program or the execution of the program. They're constant. You can actually be really good about this with JavaScript and use const and things like that, but I'm just gonna like do it like this. So let me know later on that these are like fixed at the beginning of the program and they never stop being what they are right now. Acceleration being one. So acceleration is going to be the value that I add to the velocity every tick. Okay, actually that's way too much. Can you think about it? It would only take 6 ticks or 6 loops of the code to get to top speed. So let's actually reduce this by a lot. Let's say the acceleration is even less than that. How about 0.01? So it takes like, 600 ticks, I guess, to get to top speed. Okay, so what we're going to do with go forward is I'm actually going to say this dot velocity. Let's go ahead and add on, so plus equals this dot acceleration. Accelerati. Did that say accelerati? Okay. Let's see, and then, okay, and right now I need to check if I'm at the top speed. So I'm going to add on, but if this turns out to be too much, okay, so let's ask. So if it turns out that after we add the acceleration, if this dot velocity turns out to be too high, like if it's greater than this dot max speed, then it turns out what we have to do is actually set the velocity. This dot velocity, I'm going to back you off a little bit, and you're going to be the max speed for now. Let's see how many errors we have right now. How crazy is this? Do we even have anything going on here? Let's get live. Do we have some kind of acceleration? Okay, we do actually. Cool. Okay, there we go, and we're going faster and faster, and it looks as if we've reached a top speed, or maybe not. Yeah, there we go. That looks like a top speed right there. Yeah, it's not going any faster. It's kind of stopped. Okay, so let's. Okay, that looked unnatural. So stopping is clearly not normal. But let's. So okay, yeah, the acceleration. Yeah, so there's a problem. So at the beginning of the program, this works pretty well, right? It's like slowly accelerates, but then we should probably have to coast to a stop, right? Yeah. So and the velocity as I'm changing it right now, like when I let go, think about this in the car, right? It spent all that time building up the velocity. And then when I let go, we can tell the car stopped, but the value of the variable velocity is still up where it was. We actually never wrote any code that said it should subtract it anywhere. Do you see any code anywhere that says that the velocity should be subtracted? So what we should actually do is should we do it backwards real quick? We should just do it backwards. How about this? Yeah, just for fun, because it's about time. You guys are probably wondering about it backwards. I think it's just simply, you just reverse these signs, and then let's just call it good. Let's check, see if that worked. It's probably going to be linear at first. Oh wait, now the velocity is 0, so that's not going to work. God darn it. We need to do... Actually, you know what? Yeah. Okay, let's do this then. Okay, sorry. Got lost in thought for a second. Let's actually subtract the acceleration. And if we need a minimum speed too. So like sometimes cars can't back up as this dot min speed equals, how about -3? Okay. Now it turns out I guess I didn't want to change these because instead of changing the effect of the y and x, I'm actually going to change the velocity. I'm going to subtract the velocity, so it'll be a negative velocity. So I do want these indeed to be minus and plus. So this feels redundant. I don't know about you guys, but this feels redundant, and it's probably at a later time I need to not have these written twice. Anytime you guys see your code like this, and it's like, it's like looks repetitive, then there's a better way to write it. And I'll just come back later and fix that. But let's just get it working. And then I need to change this. So if this dot velocity is less than the minimum speed, yeah, there we go. Then I want to set the velocity back to min speed. So, and we're also going to have to work on a coasting function too. So, okay, how about this? Let's take a look. Did I break everything? Sometimes I break everything by doing this stuff. All right, cool. Okay, so it's going forward and the acceleration works. How about backwards? Okay, the backwards does work. Okay, the backwards is fine. That was cool. I still don't like this, and I know you guys probably go, oh, you should package this in the same function and subtract some kind of directional thing. Yeah, I know. I'm going to do that, but for now, I don't care because it's just a little bit of redundancy. How about this? What does it mean when I let go of the forward button? Okay, I want the velocity to start to decrease, but I still want to go forward. Okay, we're going to get a little more redundant here, and later on I'm going to definitely have to refactor this and fix it up. I'm going to actually make a function called coast. How about this dot coast equals function, and what I need is actually to decrease the velocity by some particular constant, like some kind of friction, right? So what I need to do is this dot velocity, velocita, subtract some frictional amount. So how about this dot friction? Do I have that yet? I don't. So actually, let's make it all caps because it's constant. Notice the difference. Velocity is always changing, so it's lowercase. Friction is not. It's going to be the same for the whole program, so let's do it like this. This dot friction equals, okay, I want it to subtract from the velocity a little bit faster than the acceleration would add to it, I guess. Actually, you know what? I'm gonna change this to like 0.1, and I'm gonna change the acceleration a little bit faster, so it's gonna be like 0.05. Okay, so, and then I also need to go forward. So I do want to subtract from the velocity, and then I want to go ahead and cruise forward, right? So again, I'm starting to get a little antsy about the fact that I'm using this block again, but I don't feel all that bad about it, I suppose, because it's such a puny little, it's maybe redundant by like 8 lines or whatever. So let's look. Did the coast function work? Okay, so if I kind of go forward and then I let go, nope, it still stops. Okay, oh, Fleischmann. My goodness. I didn't even, know where, what is this supposed to just know to coast? Okay, no, I actually have to program the car to coast. So if the forward key is down, I'd like to go forward. If the backwards key is down, I'd like to go backwards. If neither key is pressed, I want to coast. So I'm going to do an else right here. Else car.coast. Okay, there we go. So there's the instruction to coast. If the forward key is not pressed, if the backwards key is not pressed, then coast, please. Okay, so, oh boy, zipping off backwards without me doing anything. So what's going on? What's getting triggered here? I suppose, oh, you know what? Oh, I know exactly what, and you guys probably saw it before I did. The friction is making the velocity negative, so it's coasting, and I never cap it at 0. So how about this? If this dot velocity, it happens to drop less than 0 for a second, then I would like to fix that. This dot velocity, set it back to 0, then move the car. Okay. So by the way, I want you guys to know this kind of was weird for a lot of for me and a couple other people that I used to program with. The car isn't affected by this velocity here until I ask it to move here. So after this update, it could dip negative, but we're not moving anywhere until these lines down here. So you have this time here to fix the velocity back to where you want it to be. So if it happens to drop below 0, go ahead and shove it back to being 0. Then it'll move nowhere. Okay, that should fix that problem. Let's see. Okay, now if I go forward, I coast. Yes, this is brilliant. So that actually looks a little bit better, and the acceleration feels better too. Whoa, what happened there? That didn't, oh, I'm having some issues. Why is, oh, Okay, when I capped my speed, what did I do? I capped my speed. So apparently when I hit my max speed, something's weird. So what's going on when I hit my max speed? Go forward. If the velocity, oh, look what I did. Okay, golly. If this dot max, if I get like greater than the max speed, I don't want to set it to the min speed. My goodness, you guys. I wonder how many of you guys see this stuff when I write it and you're like, oh my god, he did it again. This must be so frustrating to see that stuff and just know that I'm not going to see it until I have to. Okay, so how's that? Okay, that feels better. I don't run into those invisible walls. Coasting to a stop? Okay, that's cool. Nice. Okay, this car feels better. How about going backwards? How's that like? Maximum. Okay, yeah. Did I do it again? Look, so when I go backwards, dude, I'm seriously, something's wrong with my head. What happened to my brain? Good lord. Alright, well, at least I know what I'm doing wrong, and I can figure it out. Okay, so do I have the same problem? So going backwards now, going backwards. Mm-hmm. Which is kind of weird, actually, because maybe the friction shouldn't be stronger than the acceleration. I feel like it shouldn't. I'm actually going to reverse that ratio. It doesn't feel right. So I'm going to change the acceleration to, say, the 0.1, and I'm going to change the friction to the 0.5. So I'm going to reverse that ratio and see how that feels. It'll like seem more fun. Yeah. Yeah, that feels a lot better, actually. Okay, so going forward. Oh, wait. Do I coast when I go backwards? I don't coast when I go backwards. Interesting. Okay, well, I'll fix that. Maybe that's okay. And maybe we need to move on to a different topic, and I need to end this video. So what we did in this video, I'm going to end it here. I'm going to do another one right after this one, because I'm feeling like I got the energy. It's only 9 o'clock, and I want to rock. We have a car that coasts and turns, and we are more in agreement with the unit circle, and so our angles are making more sense, and this feels like a better car. So some of the things I'd like to do next are like have another car, and I can anticipate that being a little challenging because of moving the drawing object and rotating it. But let's stop here. And thanks you guys for watching. We added some friction, some acceleration, and fun stuff. And let's continue next in the next video. I hope you guys enjoyed this video. Thanks for taking the time to hang out with me. And before we know it, you guys, we're going to be smashing our own Rocket League 2D and making our friends say, wow. All right, you guys, see you soon.